Hey everyone, and welcome back. We're diving back into the OCSI STEAM course this week.
Yeah, taking a look at what the kids are working on.
It's week 2 already.
That's right.
I feel like time is just flying.
It really is.
So last week, I remember they were designing those traffic signals in Tinkercad.
Yeah, they were really getting into the design aspect of it.
Now they're adding in a pedestrian crossing button.
Yeah, and that's a big step because now they're starting to think about how the software, the code, is going to bring that hardware to life.
So it's not just about what it looks like anymore.
Exactly. It's about how it behaves, how it interacts with the world around it.
That's pretty cool. So are they actually programming the traffic light to think like, okay, buttons pressed, time to let people cross?
That's the basic idea. They're learning about what are called conditional statements, which is a fancy way of saying, the code can make decisions based on certain conditions.
So like, if this, then that kind of thing.
Exactly. If the button is pressed, then do this. If not, then do something else.
So it's not just a light show anymore. It's like a thinking machine. Were you doing any coding when you were, this age?
No way. It's amazing to see how early they're getting exposed to these concepts now.
And it's not just about programming, right? This if-then thinking, it's problem-solving.
Absolutely. They're learning to think logically, break down a problem into steps, and figure out solutions.
That's a great point. So as parents, we might see our kids struggling with a line of code and think, oh, they're just playing with computers.
But really, they're training their brains.
Exactly. They're developing these essential skills that they can use in any area of life.
Absolutely.
Now, to make this button work, they also need to understand something called pull-down resistors.
Yeah, that one sounds a bit complicated.
Okay, can you break it down for us non-electrical engineers?
So resistors in general, they control the flow of electricity in a circuit. Think of them like brakes.
Okay, so far so good.
A pull-down resistor, specifically, makes sure that when the button isn't pressed, the Arduino board gets a clear signal that it's off. Ah, so it's like a safety net to prevent any mix-ups.
Exactly. It eliminates any ambiguity in the signal. And for the kids, it emphasizes the importance of clear communication, even in electronics.
That's a cool way to look at it. I never thought about coding as a form of communication before.
But it really is. They're using code to tell the Arduino what to do, just like we use language to communicate with each other.
And next week, they'll be moving from the virtual world to building actual circuits with Arduino components.
I know they're going to love that. They get to see their code come to life in a whole new way.
I bet they can't wait. But before we jump ahead, there's another important part of this week's learning that we should talk about. Debugging.
Right, and debugging is basically becoming a code detective.
Because there are always going to be errors.
Almost always. Either in how the code is written, the syntax.
Like typos and things like that.
Even a missing semicolon can throw everything off.
Oh, so attention to detail is crucial.
It is. But the good news is the Arduino IDE, the software they're using, helps them spot those errors early on. So it's like a built-in proofreader.
Exactly. Now, logic errors, those are a little trickier.
Those are more about, the thought process behind the code.
Right. And that's where they really have to put on their thinking caps and figure out step by step where the code isn't doing what it's supposed to.
So if we hear our kids talking about bugs in their code, it's not just tech jargon.
Nope. They're learning how to troubleshoot, how to be resilient problem solvers.
And those are skills they can use anywhere, not just in coding.
Exactly. Maybe they can even teach us a thing or two about debugging our own tech issues.
Okay, we've talked about the push button, the pull-down resistors, and even the art of debugging. But how does all of this connect back to the bigger picture of the STEAM course? What's the key takeaway for the kids this week?
I think this week is really about bridging that gap between design and real-world application. They're seeing how their designs from last week can actually do something.
It's not just a pretty picture anymore.
Exactly. They're discovering the power of code to make those designs interactive, responsive to the world around them.
It's like they're graduating from being passive users of technology to becoming active creators.
Precisely. And next week, when they start building those physical circuits, that sense of creation will become even more tangible.
Speaking of tangible, we keep mentioning the Arduino IDE.
That's the software they're using.
It sounds like it's more than just a place to type code.
It is. Think of it like a digital workshop, specifically for Arduino.
Yeah.
It provides the structure, the language, and the tools they need to get started.
So it's a supportive environment where they can experiment and learn.
Absolutely. And it helps them catch those syntax errors early on, those little grammar mistakes in their code.
So they can focus more on the logic and creativity.
Exactly. And the Arduino IDE gives them a lot of flexibility. They can adjust the timings for their lights, try different different sequences, really explore what's possible.
It's not just about following instructions, it's about them making choices, seeing the impact of those choices.
Right. And before they jump into the code, they're also learning to use pseudocode, which is like a blueprint for their program.
So they can sketch out their ideas in plain English first.
Exactly. It helps them break down the problem, think through the steps, and stay organized.
I wish I had used more pseudocode in my life.
Yeah.
Speaking of details, let's talk about those LEDs.
The little lights that make up their traffic signals?
They're way more efficient than old school light bulbs, right?
Much more. But what's important here is that they're learning to control those LEDs with their code.
So they can turn them on and off, create the red, yellow, green sequence.
Exactly. By sending signals to specific pins on the Arduino.
It's like they're conducting an orchestra of light. To do that, they also need to understand this fundamental principle, Ohm's law.
Yeah, don't let the name scare you. It's actually pretty straightforward.
Okay, so what's Ohm's law all about?
It's the rule book for electricity. It describes the relationship between voltage, current, and resistance in a circuit.
So it's like a recipe for making their LEDs light up just right.
Exactly. Too much voltage and they could burn out. But Ohm's law helps them understand how to choose the right resistors to control the flow, make sure everything is balanced.
So it's not just about the code. There's a whole lot of science and math involved here too.
There is, but it's not just abstract. It's all connected to making their creations work in the real world.
Wow, this week is a big one for them. They're moving from design to function, from virtual to real.
And from following instructions to becoming problem solvers and creators.
Definitely sensing a lot of proud parent moments coming up.
I think so too. And it's only going to get more exciting as they continue to explore and experiment.
Me neither. But for now, let's leave the parents with a little something to ponder.
Okay, what do you have in mind?
How is Ohm's law like a recipe? Where else do we see this balance of different elements coming together to create something new?
Ooh, that's a good one. It's a great question to spark those dinner table conversations and keep those young minds engaged.
And remember, parents, you don't need to be an electronics whiz to be a part of their learning journey.
Just your curiosity and support are invaluable.
Well said. Stay tuned for part 2 of our deep dive, where we'll get into the nitty-gritty of building those physical circuits and see those virtual designs come to life.
It's going to be electrifying.
I can't wait.
Welcome back. We were just talking about the kids moving into the real world of electronics.
I know, it's so cool, taking those virtual designs and actually making them real.
It's a big step. Next week, they'll be working with Arduino boards to bring those traffic light designs to life.
The Arduino's like the brain of the whole project, right?
Exactly. It takes the instructions from their code and translates them into electrical signals that can control all sorts of things.
Wait, so it's not just for lights. They could use Arduino to control other stuff, too.
Oh, yeah, all kinds of things. Motors, sensors, displays, you name it. They could even connect it to the internet.
I'll say they could make their own smart devices.
They could. This traffic light project is just the tip of the iceberg.
That's amazing. Okay, so besides the Arduino, what other tools will they be using?
Well, they'll be using something called a breadboard.
A breadboard.
It's basically a grid with holes that lets them connect components easily without any soldering.
No soldering irons?
Nope. Much safer and easier for beginners. Think of it like a Lego base plate for electronics.
Okay, that makes sense. And they'll be using LEDs, resistors, that push-button switch, right?
All the essentials. They'll
Yeah,
get to
right.
piece it all together, make those connections, and see the current flowing through their circuit.
I bet that's a really satisfying feeling.
It is. And they'll start to understand those concepts we talked about, like Ohm's law, in a much deeper way.
It goes from being an equation to something they can actually see and feel.
Exactly. Now, I'm sure there will be challenges along the way. Building a circuit rarely goes perfectly smoothly.
Oh, I can imagine what kind of things might go wrong.
Loose connections, maybe a faulty component, or even a flaw in their code that they didn't catch before.
So those are all opportunities for problem solving.
Exactly. They get to troubleshoot, debug, figure out what's going wrong and how to fix it.
It's like being a detective.
It is. And those skills are valuable not just for electronics, but for life in general.
Because things don't always go according to plan, right?
Exactly. Knowing how to adapt, how to think on your feet, is essential.
So how does the Arduino IDE, that coding software, help them in this new environment?
Well, it's still their control center, but now, instead of just manipulating virtual components, their code is talking directly to the physical circuit.
So it's like they're giving the Arduino a set of instructions.
Exactly. And they can adjust the code, test it out, make changes, until they get the behavior they want.
It's a constant loop of learning and improvement.
It is. And that process, that back and forth between design and testing, is at the heart of engineering.
So they're not just building a traffic light, they're learning a way of thinking, a way of approaching problems.
Absolutely. And with Arduino, the possibilities are endless. They could move beyond the traffic light and start exploring, controlling motors, sensors.
Wow, it's amazing how much they can do with this technology. So debugging a physical circuit, is that the same as debugging code on a screen?
It's similar, but there are some unique challenges because now you're not just dealing with the code itself.
You have to consider all the physical components too.
Exactly. A loose wire can cause just as many problems as a typo in your code.
So they really have to think about the whole system.
They do. And that's where a tool like the multimeter comes in handy.
A multimeter, what's that?
It's a device that lets you measure voltage and current at different points in the circuit.
So they can actually see if electricity is flowing where it's supposed to.
Exactly. It's like having X-ray vision for their circuit. If an LED isn't lighting up, they can check if it's getting enough power.
That makes sense. So they're not just guessing. They're using scientific tools to figure out what's going on.
Exactly. And through that process, they're developing a deeper understanding of how circuits work.
It's like they're becoming little electricians.
In a way, they are. They're learning the principles of electricity and how to apply them in the real world.
So why is this step of building physical circuits so crucial in the STEAM course?
It's where theory meets practice. They're taking all that knowledge from designing and coding and putting it to the test.
We're breaking the gap between the virtual and the tangible.
Exactly. They're experiencing firsthand how their ideas can take shape in the physical world.
And I bet that's a really empowering feeling.
It is. They gain confidence. They see that they can create things that work, that they can solve problems.
It's not just about circuits and code. It's about building those essential skills that will serve them well in any field.
Couldn't have said it better myself. It's about unlocking their potential, nurturing their creativity and problem-solving abilities.
Well said. Now, as we head into the final part of our deep dive.
Yes, we'll be looking at.
Welcome back, everyone, for the final part of our deep dive. It's time to see those traffic light projects come to life. I bet there's a lot of excitement in the air as the kids get to build these circuits.
There is. It's amazing to see them take those virtual designs and turn them into something real, something they can hold in their hands.
It's not just about following instructions, though, right?
Yeah.
There's still plenty of problem-solving and critical thinking involved.
Oh, absolutely. They're taking their ideas from the digital world and translating them into the physical world, and that always comes with its own set of challenges.
So parents, if you hear your kids talking about debugging their circuits, it's not just about fixing a simple mistake.
It's about understanding how everything connects and how one small change can affect the entire system.
It's like they're detectives, trying to figure out what's causing the unexpected behavior.
Exactly. And they get to use tools like the multimeter to investigate, to measure voltage and current to see if electricity is flowing where it's supposed to be flowing.
It's like they're getting a glimpse into the inner workings of electronics.
And through that process, they're gaining a much deeper understanding of those core concepts.
Yeah.
Voltage, current, resistance.
It's not just theory anymore, it's hands-on experience.
And there's nothing quite like the feeling of seeing those LEDs light up in the exact sequence they programmed.
That's got to be a real confidence booster. It shows them that they can take their ideas and make them a reality.
And as they gain mastery over those concepts, their curiosity and their desire to explore just grows.
This STEAM course is as much about fostering those mindsets as it is about teaching technical skills, wouldn't you say?
Absolutely. Resilience, problem solving, critical thinking, that growth mindset, those are all essential skills for success in any field.
And who knows, maybe one of these challenges will spark an idea for a future invention.
I wouldn't be surprised. They're learning that they have the power to create, to innovate, to make a difference.
That's so inspiring.
Yeah.
So as we wrap up our deep dive, KOEIGO parents, I want you to take a moment and really appreciate the incredible journey your children are on.
They're learning so much more than just circuits and code.
They're developing the skills and the mindsets that will help them succeed in whatever they choose to do in life.
And remember, parents, you don't need to be a tech expert to be a part of this journey.
Your curiosity, your encouragement, your willingness to learn alongside your children, those are the most valuable things you can offer.
We hope you've enjoyed this deep dive into the OCSI STEAM course.
Keep exploring, keep questioning, and keep that spark of curiosity burning bright.